Well, it was, it was typical of a really interesting development in that I was looking for something else. And it was a like PCR was the possible outcome of a solution to a hypothetical problem that didn't really exist. I mean, I was working on trying to sequence single base pair, think what they call SNPs today, single nucleotide polymorphisms, because those were medically important. And I was trying to do it with oligonucleotides because I ran a lab that made them, and we had really improved the efficiency with which we made them over the 3 or 4 years prior, so that we could make them a lot faster than the company CETUS that I worked for could use them. Okay. I had 7 people working for me, and I was thinking, well, I'm either going to have to cut the staff down to like about 3, because now we got these little automated devices that'll do it, or I'm going to have to increase the demand for oligonucleotides. So I started thinking of what else can you do with them, and I thought that's possible that you can make a rapid clinical assay for single base polymorphisms. And like sickle cell anemia was a good example. People there. That took, back then, maybe you'd go into a clinic and they'd take a sample and maybe 3 weeks later you'd know, which is a lot of agonizing kind of. And I thought, it'd be nice to have that in one shift in the hospital, kind of. You'd go in and they'd let you know. And I thought oligonucleotides maybe were the answer there, but I was really, I was a chemist. I still am a chemist, and I really didn't have an appreciation for the hugeness of the human genome compared to, say, a 5,000 base pair plasmid that I was using as a sort of a model system, and I was thinking of this method that would require a couple of oligonucleotides. And one of them would sort of be a control, but they would be pointed right toward each other, just like in a PCR reaction. And then I was thinking of how am I going to get rid of excess deoxynucleotide triphosphates or something like that. There was a couple of technical problems I was trying to solve, and one of them, the way I decided to solve it was to like run a sort of sham reaction first with the oligonucleotides in place in the sample, and then add my radioactive tracers and stuff and run it again, and because it was going to use up it was just not for the idea at first of like duplicating the signal, but then I realized the side effect of that was going to be that I was going to double the signal if there were enough like deoxynucleotides available, and I was trying to get rid of those if there were any coming in with the sample.
But you were out driving. You had this in your head, and you were thinking about it constantly, and then you just realized that there was a way.
You don't think in the lab as much, Yeah. I usually think. I was spending my weekends up in Mendocino at a little cabin, and I would drive up every Friday night and come back on Sunday night, and that was it was about 2.5 hours. And it's sort of you've got something to do with your hands, and you can't do anything else. And so you think. And that's when I did most of my thinking, actually, because the day-to-day life in a laboratory doesn't allow a lot of, there's all these letters in your inbox, and there's your phone ringing, and there's all these people that you have to deal with and stuff, and you don't have really that kind of time.